Welcome, everybody. Good morning, good afternoon. Welcome to today's community conversation. This is the Dynamo Office Hours. We've got Jacob Small today. I'm Sean Hurley. I'll be your community host. All right, let me get my, no, we're going back to that one. I got to give everybody the spiel on community conversations. Even though you know it by heart, there may be some that don't. Community conversations are virtual meetups. They're featuring expert speakers like Jacob from across the community. They range from deep dives, product tips and tricks, live demos, industry talks, panels from all different experience levels or for them. And they're welcome to you too. If you have an idea for a panel or you have expertise in a topic, you can easily submit your own community conversation for consideration. We would host it for you. All right, now the fun one, the lawyers. Safe harbor statement just simply says that if we talk about anything in the future, that it is not a promise that you make all purchasing decisions based on the products as they ship today. That's pretty simple. You know, we can talk about cool stuff in the future, but you know, plans change and stuff like that. So only make those decisions based on the products as they are. Next, please. Oh, we didn't have our standard one. I'll just go over it verbally then. We're missing one slide, Jacob. There we go. All right. The line's been muted to reduce the background noise. We do invite you to turn on your camera if you feel comfortable with that, your video, so that we get a kind of we get a little bit of a virtual seeing people's faces and reactions and grimaces and all that good stuff. If you have a question, feel free to ask it in the chat or use the Zoom in the bottom right and raise your hand, and we will call on you to unmute. Or you know, if you're shy, you can go in the chat. And we will ask Jacob when he gets moments of breaks in between topics. The session will be recorded and a link will be posted on the event page, as well as put on the Dynamo Office Hours playlist on YouTube. So I'll put a link to the YouTube playlist throughout the event so that you can share that with others that may benefit from it. I am Sean Hurley. I'm your Autodesk Community Engagement Manager. I am a geeky technologist in Bend, Oregon.
And I am Jacob Small. I'm a technical consultant with Autodesk Consulting Organization. I'm a Dynamo Form junkie based out of Boston, Massachusetts. And not with us today for a great reason is Solon Moore, the product manager for Dynamo. He describes himself as a curious human being, also based out of Boston. He's out today because he just had another baby. So really happy to see his family expanding and wish he was here, but totally understand why he isn't, and it's a great reason to not be in attendance.
Yeah, all right. There's gonna be more Sauls in the world. That's good too.
Yeah, also true. All right, so let's talk about today's session. So this session is generative design from scratch. Bit different from our usual content. And a couple of reasons for that. This was kind of like 2.5, almost 3 years ago, was originally approached to say, hey, would you be willing to do these community conversations and show people generative design? And I was like, yeah, but we have a whole bunch of stuff we have to cover before we get there. So this is a session that's been like 2.5 years in the making now. So I'm really thrilled because today we are going to be starting from nothing. That's right. The presentation is going to start with a blank file, and we're going to do all the generative design presentation stuff, our sort of authoring stuff, right up to getting some initial studies. We're not going to do the full bake it for 2 hours kind of bit to get the perfect optimization, but we'll talk about what that would look like when we actually get there. All right, so without further ado, let's get into the presentation. So 2 cabins, both alike in dignity. So basically this is coming at this problem, and it's a typical problem that we see where designers will have somebody say, a customer come to you and say, hey, we want to go ahead and we want to start a design for X, Y, or Z. And the question are, you know, where does it want to sit on site? How do we want to position the building? Stuff like that. Now, this isn't a super complex graph. There's going to be a lot of stuff kind of going on in it, but it's not going to be kind of over the top. The basic goals are 2 cabins on this wood plot. We want to keep the massing simple, kind of rectangles or sort of rectangle adjacent to rectangle. We want to work with sort of prefab modules, so we don't want to sort of adjust stuff in like 1/2 of an inch increment. We want to be in that sort of 16 inch or 24 inch or whatever we might have in mind sort of increment. We want to maximize the separation between cabins, keep them sort of as far apart from each other as possible, while obviously still fitting them on the site. Make sure we have minimal impact on the site trees and keep it to about 1,500 square units per footprint. And I'm saying square units because we're going to be working kind of unitless, because we're going to pretend we don't even have a site plan yet. That's right. We're going to build a tool to get started with the project when we actually get that site data. And this is something that I wind up doing all the time in my consulting roles, where companies will say, hey, we want to do generative design for this sort of piece or that sort of piece. And it's, okay, we invent the site to kind of go. Anyway, we also want to have that fast timeline once we get started. So that's why we're going to try and keep this done as kind of this prep the exercise before we actually get started. All right, so without further ado, we're going to pop over to Dynamo, and yep, brand new file. So the first thing that I need to do is I need to understand how to make a general site. So a site typically consists of a polygon of some sort, which means I need some points. So I'm going to go ahead and actually start with a vector. And we're going to take the x-axis vector, and then I'm going to go ahead and scale that toward .scale. We're going to scale that vector by a random number, math.randomList. We're going to take a whole bunch of random numbers actually, and we're going to take a value of 150, I think sounds good. And then we'll add 100 times whatever that number is to it. And then we'll wire that into our vector.scale. Let's use a number here. And I'm going to generate 5 points, which would generate a 5-sided polygon. There we go. And so now I have 5 vectors of different lengths. And remember, vectors don't have a display, so we can't actually see these yet, but they all sort of start off that internal origin, have an X, Y, Z component, just like a point. We can start to play with that as well. But these are all sort of perfectly aligned to the x-axis. So we also need to rotate them. So I'm going to take that same random number and I'm going to use a list.sort command with a value of whatever my number is times 360. So this is going to take those same random numbers ranging from 0 to 1, and it's going to sort them so that they're in the right order after multiplying them by 360. So I get a value of 46 degrees, 51, 228, 253, 297. Now I can use a vector.rotate, which is going to ask for a vector, an axis. Let's use our z-axis. And a number of degrees. So there we go. Things now have a y component to them. As point, we can convert our vectors over to a point. We now have 5 points. We'll zoom out. Polygon by points. Then let's have a look at our shape. That's a pretty decent site. I've seen some sites that look like that in the past, but maybe we want to be able to sort of toggle this and make new ones as we go. So I'm going to make a true false Boolean right here. This is going to do 2 things for me. It's going to give me the capability to quickly generate new polygons while also keeping things from regenning every single time. So we're going to write an if statement in design script that starts by just saying, what is our test? Regen, yes or no, true or false. If it's true, we're going to go ahead and we're going to return the number, which I'm going to call n. If it's false, colon, we're going to go ahead and we're going to return null or no data. Now, I'm going to set this to false to start with. We're going to hold down shift on my keyboard and drag this over to there. And so now everything's in an error state, wire that in. But now when I want to generate a new polygon, we can just toggle this Boolean and we get a new polygon. And we'll do this over and over and over again until we get one that we really like. From here, we're going to remember that because we don't want to have to keep generating new polygons over and over and over again. By patch, we'll go ahead and we'll start a surface next. And then from that surface, this is the extent of anywhere on my site I could put stuff. One of those things that we know we're going to have is going to be trees. We're going to be using a point by coordinates. Sorry, point at parameter within our surface. And now I need some more random lists. I'm going to copy all of this right down here because we don't need to do that again. And this is going to generate, again, 5 random numbers ranging between 0 and 1. That becomes my U and my V. And those could be 5 trees. But if we're actually on a wood lot, we probably have a lot more than 5, right? Let's call that 250. That's a good amount of trees, but a bunch of them fall outside our site. Does intersect. Does this point intersect with our surface? Filter by bool mask. Here's our mask. Here's our list. Let's just count how many trees we're going to have. This will result in 138 trees. It's a pretty good amount, I think. All right, so remember the ones that are inside our original polygon, all of this data, hide that data. Here we go. All right, so now with all that stuff hidden, if I wanted to generate new trees, just like before, we could just toggle this over. Right, and this is going to give us new completely random layout for trees every time I hit false, and then toggle it back to true. I'm going to leave this over as false, and then again, that data remember node, because it's serialized the good stuff into the file, I'm passing over the null because we can't pass the null into the function and get good stuff. So as a result, this is always going to be there. I don't have to worry about those pieces rerunning next time out. We'll get rid of that for now. Our site data is prepped. What are we looking at for time? 19 minutes in. All right, we're doing pretty good. Next piece I have to do is I have to start worrying about defining our cabins. Well, we know we want those to be rectangles, so let's use a rectangle. And we're going to use a rectangle by width and length. And so this takes an input for our width and our input for our length. I'm going to go ahead and I'm going to zoom in on that right now. There we go. To get the length, we're going to use a number slider. And we're going to set the low point on this to 25, the high point on this to 50, and the step to 2.5. So every 2.5 feet or 2.5 meters, 2.5 millimeters, whatever our units might be. Before I copy that, we're going to name this building A width. And actually, let's just get rid of that building. I'm just going to call it A width. And that A width is done. One more thing, right click it. We're going to mark it as an input because this is going to be a variable. Now over to B width. Whoop. Trying to keep an eye on the chat as we go.
I got it, don't worry.
All right, so we've got width and length. These are variables. I can adjust them, scale them up, scale them down as we might like, but that's kind of boring for the footprint of a building. We probably want a little bit more than that. Let's go ahead and let's duplicate all of this. I'm going to call this a addition width and a addition length. And we're going to chop down that size. Let's call this between 10 and 20. 25. 10 and 25. All right, so now I've got 2 rectangles. And we can, again, adjust those values and get different shapes as we might like. Don't need to worry too much about flexing stuff here, but we're putting our addition right on top of the other piece. I want to be able to put that addition kind of on the perimeter of that other piece. So we're going to use a curve.coordinate system at parameter. Take our original curve, and we now need a parameter. So I'm going to call this a addition location. And we're going to set the low point on that to be 0 and the high point on that to be 1. And we're going to step by 0.05. And obviously, different projects, we might want to configure these numbers to be different. But it's pretty easy to come in and make some changes in there, or you can even bulk process those by editing the text files directly. Transform takes our initial geometry for our addition and our coordinate system, and then we can put that in place. And that looks pretty good, but it's a little bit not really well positioned. So let's do a translate. Our original geometry for a rectangle by x divided by 2 for our width. And notice that's now kind of aligned with that coordinate system. And now if I use that as my geometry, we're looking pretty good. We can go ahead and hide all of this stuff. I'm going to use these two pieces. I think I saw John Pearson join earlier. My favorite piece of Monocle, I'm addicted to this, is the combinifier right there. Thank you, John. Now I've got one list that consists of my two polygons, and I can adjust the location of that polygon anywhere we might like around that other polygon. I can adjust the size of that rectangle anywhere I might like, right? We can do kind of parameter manipulation individually like crazy as we might desire. We'll make a surface by patch from this. So now I've got a single set of surfaces, and then surface by union. So now I've got a single surface which represents the footprint of my cabin. And now we need to do that entire thing a second time. So there's a couple ways we could do that a second time. We could take this entire piece, everything, and then copy it down. Or maybe customer might change their mind and they want 3, and then copying that stuff over and over and over again doesn't necessarily make sense. So what I'm going to do is I'm going to actually just copy my inputs. Then I'm just going to change all my A's to B's. B width, B length, B location, B addition width, B addition length. And then we'll just sort of spread these guys up. Kind of like shuffling a deck of cards right there. And then we can take these pieces and just do, again, combinifier. And one handy tip, I'm going to hit Tab. Tab, when I have a node selected, selects all the nodes that are connected to it. And then I'll disconnect this, and then I'm going to hold down that Shift button on my keyboard, drag it out. There we go. So I don't have to worry quite so much about sort of revamping this stuff. And there are actually even better ways to sort of manage the connections on this. It's probably would be better to just combine all the lists into one list and then transpose. But I like to show that tab trick actually, and use a little bit more of the combinifier here. So we're going to go this route with it. All right, one more. Okay, so now everything's processed over until the end. Let's go ahead and let's change our information about our parameters a little bit. Something like this. Make sure we've got 2 different looking buildings. And we do. But we've got a surface and a poly surface. So let's look at why that is. Because I did that joining, what's actually happened here, there's our surface. Here's our poly surface. It's interesting that I managed to get a perfect fit on that. Hey, that doesn't really work. So what's happened? When I did the list create, it joined the list to the list. So I need one more list.transpose inside here. And then I want to make the surface by the patch. And union those. Turn off our preview, and now we've got 2 different buildings. Quick time check, we're halfway through, doing pretty good for time, but we still need to put these actually on site, right? So I'm going to go ahead and start that process. I'm going to do one of these sliders here shortly. Surface.coordinate system at parameters. Similar to our point at parameter, we're going to look at the overall domain of the surface in terms of these sites width and length. Oh, that's a polycurve by patch. Missed this step. So there's our overall site. Here's our surface. Now that I look at this, our site might be a little bit too small relative to our buildings, huh? We might want to scale that up. We'll leave it alone for just a little bit. I'm going to take this value and I'm now going to change the name AU location, set the minimum to 0, the maximum to 1, the step to 0.05. Actually, yeah, that's probably good. And now I can wire this in to our U, but we know we need one for each building, right? So U location, combinifier. And then we need our V locations as well. Wire that in. And so now I've got a coordinate system that I can adjust individually for each building within the overall domain of the surface. And if you don't quite remember what coordinate systems are, you can go back and check some of the previous examples. We did a whole series on geometry, talking about the abstract stuff in particular. That's one of those things that you really have to have that good handle on before you can do this type of stuff in generative design well. All right, so we'll pull our UV parameters for our location over here and then copy these down once more because I might want to be able to rotate these as well. So we're going to say a rotation, put that on my clipboard, B rotation, and then coordinate system dot rotate. There we go. There's two options here. There's the origin axis degrees or plane degrees. I like plane degrees for this. I'll show you why in a second here. We'll pop all of this stuff out over here. And what's nice about coordinate systems is there's a handy way to pull the XY plane. And if I know the XY plane, I know it's going to rotate about the coordinate system's previous Z. And now I can pull the two coordinate systems and rotate them independently. Let's go ahead and hide all of that geometry. Now, what's happening here? We've still got that as 0.65, and we probably don't want to limit that between 0 and 1. We probably want to limit that between 0 and 360. So I'm just going to multiply that by 360. We could change the number sliders to give it a thing that people might understand a little bit more if they weren't computation designers, but we are, so we can work with that. And then now we can see those coordinate systems as I flexed them before. We can now rotate them as we might desire. Whichever angle we might like. All right, so we've got coordinate systems that we can flex now. Let's go ahead and hide all of those. Transform that geometry for each one of our buildings by our new coordinate systems. 2 coordinate systems, 2 buildings. Don't have to worry about lacing. And there we go. Go ahead and hide the ones that we built back at the base. Let's turn on our polycurve. So like I said before, this looks like it might be a little bit small. So we're going to generate some new sites. And that means we also need to generate new trees. And still too small. Let's actually turn this into 100 plus 100. It's looking a little bit better. I could see how that could work out. Let's preview our trees. That's looking pretty good too. Again, because I don't want those to regenerate every time I run generative design, we're going to go ahead and close those and keep those in our data.remember now notes. All right, so 32 minutes in, doing great for time. Everybody's still with me. We haven't lost, we've actually picked up a couple people, so I must not be too boring. All right, let's go from here and let's start talking about how we might check sort of and evaluate some of this stuff. Well, the first thing that we know we want is if a tree touches a building or is within X distance more likely of a building, it's probably going to have to come down, right? We want to maintain as many of those as possible. But I've got right now 131 trees and I've got 2 buildings, I don't want to have to run 262 tests. I'd rather run 1 test, but I can't run less than 131. So instead of doing geometry comparison 262 times, we're going to go ahead and build a poly surface by joined surfaces for both of our buildings. We'll turn off this preview for now. So now we've got one object, distance 2, from our poly surface to each one of the trees. We can get a distance, and this is going to give us 131 distances. I cut the number of tests down that I had to sort of perform, right? And if it's inside, like our first tree happens to actually fall inside, usually I have to scroll through this, so I'm really happy that happened. We're going to get a value of 0. But what we care about is anything that's within is A less than 10 units. We're going to say that tree is too close to the building. It's going to be lost during construction, or we don't want branches going into the building. Filter by bool mask. Here's our mask. Here's our list of trees. Count our list of trees that we're getting rid of. 119 are in out. Actually, we did less. We probably want to do greater. That looks more like it. 12 trees that are out, 10 trees that are in. Let's go ahead and let's color these. I'm going to turn off all of this geometry preview as well as this. There we go. And now we'll take those geometry color by geometry color. List.create 1, 2 for A and B. Palettes. And what do we want for colors? This is our geometry. First color, I'm going to go ahead for the trees I'm going to keep. We'll make them green. It's a nice shade of green. And for the trees that we got to say goodbye to, we'll go ahead and we'll make them red. Join those into a list. Color the geometry. Hide this geometry. And now we can see pretty easily where that stuff might stand. So now I got to decide, how do I want to score my trees? So I always like my generative design studies to be set up for all variables to be minimized. So I don't have to worry about, was this one to minimize or maximize, or how do we want to sort of toggle that? I just always do minimize. So what I'm going to do is I'm going to say each tree is worth a penalty of 10. And that penalty might want to change. Put a watch node on the canvas. Mark that as an output. And name it tree. Whoop. Tree score. There we go. Pull that over, and we have our first evaluation done. I probably want to be able to see these buildings too, so I'm going to go ahead and grab all of this stuff, copy it down here, and wire it in. Red and green are probably not the right colors here. I'm really bad with colors. Usually I lean heavily on Sol. We'll do that one in blue. Yeah, that looks okay, I think. All right, so you can see we caught this tree. It winds up getting lost because of where it is. But if we position that building a little bit differently, like moved it back a bit, we'd still lose that, maybe keep that. And generative design is going to be able to start to do that sort of exploration for us. But there is one thing that's very apparent right here, that this building doesn't actually fall on our site. Usually people get pretty upset when you build the building not on your property line. So let's go ahead and talk about how we could evaluate that. My preferred method for this is to use a geometry.intersect. And so we're going to take each one of our buildings and we're going to intersect them with the surface that we built back here. Pull that up so I can trace this out. And that's going to give us 2 new surfaces. We'll hide this geometry for now. And you can see part of my building is getting kind of cut off there. But I've got 2 surfaces, right? So we can now say surface.area. And that's going to tell us what the area of each one of those pieces is. But what if I pulled this down to location, make that a little bit less. There we go. Now it's not even on the site anymore, but I've got a value in an empty list. So what I like to do here, after I pull my surface area, is I like to add a 0 to my list. List dot add item to end. My item is going to be a 0. My list is going to be my list of values. And we want to make sure that we use this list at level 2. And sorry, at level 1. Nope. Item, what is the method for this? Level 2. Why can't, oh, haha. These levels. Level 1. No. One more time, Jacob. How do you solve this? Of course, I'm forgetting. Let me go and check my cheat sheet. Atom end at level 2. Uncheck use levels there. There we go. Could have sworn I had that before, but wasn't seeing that. All right, interesting. But now I can do a math.sum and get the area that I would be able to build for each building. And we know that we had a target of 1,500. So we'll go ahead and subtract 1,500 from whatever my area is to get the difference between 1,500 and the other value. But we probably want that to be the absolute value, so that if I'm negative or positive, doesn't matter. We're always going to return that value. And then we'll sum that up. I'm going to need a few sums here, so we're going to do that way. All right, and I also know that if a building's not falling on site, we probably want to have a pretty heavy penalty for that. So let's go ahead and take our surface area and we'll copy that down. And I'm going to take the area of my original surfaces, right? So these are the buildings as I had them on site. We don't need to see this anymore, and we want to see our buildings. There we go. And now we can ask, is A equal to B? For the sum of the intersected surfaces versus the overall surface area, are those two values the same? True for the one that's in the middle of the site, false for the one that's not. Turn this into an if statement. If they're equal, we're going to return a value of 0. Otherwise, we're going to return a value of 10,000. Really big numbers. All right, sum those up. I already got a sum node here. There we go. And we've got a couple more scores. What are we at? 41 minutes. I'm a little behind now, thanks to that snafu I had earlier. We'll rename the tree score.
To be fair, Jacob, your clock might be fast. I show 1036.
Oh, sweet. I'm actually behind. I'm going faster than I thought. All right, fit score right here. And this piece we're going to call area score. And again, the goal is to minimize these. So our fit score is always going to be really high. If the building doesn't fit, our tree score is going to grow as we impact more trees. Our area score is going to grow as our buildings get to be too big or if they get to be too small. So we're doing pretty good overall for all of those pieces. The last piece we have is our separation score. Distance 2. And we're going to take this list and we're going to break it apart. So we're going to take that transform geometry and boom. I can't remember what John calls that tool, but that's another one of my favorites. You do have to sort of prep that when you were to build this graph. So if the client sort of said, I want multiple of these, but that sort of explodey tool, the list breaker, whatever it is, I think it might be somewhere up there. John can type in the chat what his deconstruct the values tool is, but I can now go ahead and I can sort of pull that individual piece apart and get the distance from between those two items. So we want to maximize that. So let's take that value and multiply that by -1. Right. So as they get closer together, we're going to get a smaller number. As they get further apart, sorry, as they get closer together, we're going to get a number that's closer to 0. The POW list, thank you, John. As we pull those pieces together, it's going to get closer to 0, which is going to be bigger than if they get further apart when it gets to be further from 0. All right, so now we have our separation score. And we're looking pretty good overall. I've got 4 different metrics that I can evaluate for, each one kind of independent of itself. We might have a perfect score in terms of area that impacts a lot of trees. We might have a perfect score in terms of fit if we put one building right in here and another right there and they basically touch. But if they're touching, we're going to have a very bad separation score. So you can sort of see how all that content kind of works itself through. The last piece that I want is, I always like to do this. I take all my metrics and I go ahead and I combine them into one. And then we will add one more output, make sure we mark it as is output, and name it, whoop, I missed a step, overall score. And I got to sum these first. All right, so that's the score of this design. If I take this and I pull it over here, all these pieces that we'd previously marked as inputs, if we adjust them, we're going to get a new score. And that's basically what building the parametric models that drive generative design is really all about. I'm going to pull my B building a little bit further out so we get something that's a little bit better, still falling off site. So let's pull one more piece. You can see we get a pretty good piece there, but our separation score is going to be pretty horrible relative to the overall, but at least we're both fitting on site. All right, so now I would usually take the time at this point to document my graph. I'm not going to do that here because time, but this is really where we'd want to sort of combine things together, clean up our node layout. I was pretty good about how I laid all these pieces out as I go, but stuff like, hey, this is where I'm displaying the buildings. We can go ahead and make a group, create a group from that, set our colors. You can use the predefined group styles in Dynamo 2.13, or Monocle's got some handy tools for that as well. But stuff like this should always happen in this graph, because again, we don't have the site plan yet. We're going to get one eventually. Maybe it's going to be tomorrow. Maybe it's going to be next week. Are you going to remember what we did here in 30 minutes worth of work? If not for having that sort of annotation to understand where we might want to change stuff, maybe not. In any case, we'll now go to a plan view. We'll zoom extents so we can see kind of the extent of everything that's on site. I would also usually at this point start setting up my content. So I'm going to send this out. I'm going to call this thumbnail to cabins thumbnail. And then we can go into our extension menu and look at our properties, fill out our properties next. I'm going to attach my 2 cabins thumbnail there. Description, graph to optimize separation, design of layout for 2 cabins in a wooded lot. Name and URL L. We'd obviously want to fill those out. Any other custom properties you might have, definitely put those in there too. I'm noticing I still haven't saved stuff, which I'm going to go ahead and I'm going to do that now. Call that live demo. And then I'm also going to go in, I'm going to look at my graph status. We'll go to extensions. And this is where I change the graph to be none over to generative design. No issues, which means I've set everything up, maybe right, hopefully right. I'm missing my overall score output because I deleted it after pulling it over there instead of moving it back. So we'll wire that back in. And you can see as you start making changes, those things show up. I'm in automatic run mode, so it's finished itself off and is working well. Change this over to manual. The entire graph has been authored with our sort of cabin design happening over here, our cabin situationing or locating happening here, and our tree evaluation happening here, our cabin sizing and fit evaluation happening here, and our cabin separation evaluation happening here. Whole graph is done, 30 minutes on to the next phase of the process, which is to export for generative design, or sorry, to execute in generative design. So we're going to go into our generative design menu, hit create study. And it always opens up underneath something else on another window for me. So I'm digging around to find where it is. Here we are. Back over to Dynamo and then put generative design on top. And normally I'd have to go and path this, but I pathed this earlier. So we can just go ahead and click live demo. Live demo random. I always recommend starting with a random study to sort of see, are we in the general realm of where we might want to be? So we can configure our inputs, addition length, addition location, addition width, A length, A rotation, A U location, A V location, A width, B data. We've got a couple pieces. This might not really have been optimal in terms of the way that we sort of configured stuff, in terms of which comes first. So we might want to sort of reevaluate those later. But all our A stuff is happening before our B stuff. So I'm pretty happy about that, and we can let it run. We'll go ahead and we'll generate 40 random solutions. Maybe good, maybe bad, maybe not. But let's find out what we get. So while that executes, I'm going to go ahead. I'm going to pull up in Task Manager. We've talked about kind of how generative design runs a few different ways now, but in particular, it's worth noting that if you go over to your Details tab, you'll actually see, if we sort by CPU usage, you'll see these REST Dynamo core instances sort of show up and disappear, and then show up and disappear, and they're always using most 1/8 of the overall compute power, so about 12. Sometimes they'll pop to 13. And effectively what that's doing is it's going through and it's evaluating all of your graph instances in the background with 6 concurrent instances of Dynamo running headless in the background. You don't see them, but it's doing all that exploration for us. So we've got a few different options, and we could go through and we could start to evaluate stuff. Let's look at just stuff that has a good fit score. Hey, those are our upper echelon of fit scores. It looks like most of them have something that falls in some way off-site to sort of, throw the dart and see if it's a good design. Clearly isn't really working very well. So let's go ahead and let's start our next graph setting. We could do space evenly. We could do like this. Let's go ahead and start with optimize in this case though. Inputs, again, we're gonna vary all of our inputs because we don't know what's good, what's bad. We don't have anything we wanna set. Our goals, again, because I set these up to always be minimized, we're gonna set those to always be minimal. If I hadn't multiplied by -1, our separation score would want to be maximized though. And then generation settings. So this is a 20 by 10 generation. So that's going to say, take 20 random samples, look at the top 25% or so, and use that to inform the next generation. We're going to have 10 different sets of 20, always informing the next round by what was well performing the last time out. All right, so now we'll call this optimize demo. and then we hit generate. Running through, we get our first round of solutions, which is the first set that had everything kind of showing up on site. We don't see anything until that session finishes all the way through. We're through 4 of our 20 generations, 5 of our 20 generations, 7 of our 20 generations. Now let's come in here and let's look at just the ones where the building fit on site. And it's interesting, it's starting to sort of pull this stuff over where it's got one piece that's kind of off in the corner. Sadly, I have a bug because I was testing something for the generative design team in terms of the way this stuff works. But yeah, everything shows up kind of scrambled for me when in my geometry preview as I get going. But we've got some decent scores here overall. Our fit score is kind of perfect on this group, but let's do one more optimization study. And with 10 minutes to go, I might actually be able to get this to finish. We're going to do 100 samples 100 times. So we'll hit generate once more and let that run. This again is going to take a good bit of time. More than what it's taken before, but still we're a little bit ahead on where I thought I would be. Maybe it'll finish inside of the 5 minutes. The one thing that is missing from here, and I didn't cover, is bringing that data out to our design application of choice, right? When it's all said and done, I probably don't want to be living in just Dynamo. I've got to move into Revit or something like that. So that might be something like, hey, let's make a family instance from this geometry, or let's go ahead and place some curves for our exterior walls or something along those lines so that we can actually use this as a design tool going forward. All right, while that cooks, any questions? I usually have a question slide, but I think I deleted that one by mistake.
No questions right now.
Why did you make the fit score a part of the study? Shouldn't it always fit on the site? Maybe, maybe not. So computers are good at exploring stuff if I sort of combine stuff, but what if the building is like oh so slightly over the edge of the site? Everything else is absolutely perfect about the design. It misses every tree, but it overlaps that site by a 1/16 of an inch. A human's going to be able to look at that and say, here's how I'm going to fine tune it. And then we're done, right? The computer, on the other hand, is going to say, well, this is pretty good. And it's going to take a really long time to make that fine tune sort of sample. This is the sort of design that sort of tooling that we want to sort of allow it to explore the way it would naturally. Now, I could have changed the way I built my coordinate systems by forcing the coordinates to always be inside the bounds of the site. There's a few different ways you can do that. It involves geometry intersections or geometry tests, which can be a little bit slow. It'll still work, but that's only going to do that for our coordinate system, not necessarily all of our buildings. So we do want to make sure that we're sort of accounting for those pieces overall. Great question, by the way. All right, anything else? Nothing else in the chat. While this runs, we can go ahead and start our wrap-up stuff. Next Dynamo community conversation is December 8th. That is going to be our office hours year in review. This is our second year in review session where we're going to go back and talk about the things that we talked about over the last year. It's been a lot, from Civil 3D integrations, Format integrations, getting deeper into Python, all of that sort of stuff. So looking forward for that. That's again on December 8th. We're taking a break for Thanksgiving because both Sean and Sean and I will all be off that week. But we'll come back together on the 8th, and then some more things to come in the next year. Sol and I actually have some time on our calendar to, assuming he's back before that meeting, to go over and talk about what we're going to do next year. But if you do have recommendations or things you'd like to see, we'd love to hear from you in terms of what that kind of content that you're after and sort of things that might help you in the conceptual nature, ideally.
Hey, Jacob.
Yeah.
I would also like to add that on the community conversations calendar, I'll just put some helpful links here, but on that calendar, you'll find a generative product roadmap event in January. So that's out there now too.
That is true.
And people can even put some of their questions in a Slido before the event or do it during live on the event. So.
Yeah, great point. Yeah, and I always love those roadmap sessions because we learn a lot from interacting with users, and it's good to see kind of what people are really excited for. So.
And if you want to be a community conversation speaker, it's open to everybody. You could lead a panel, you could do all kinds of different things. Just if you have some expertise, you can just submit it on the little session proposal. We'd love to have that. I'm kicking around some ones that'll be fun, and Jacob's volunteered himself for like a solution one. We'll start doing those next year. We'll just maybe once a quarter or something like that, put together a panel of experts in a certain thing and allow people to throw out like a challenge and then see who on the panel can do it live. I'm going to throw money behind Jacob. It'd be fun.
Make no purchasing decisions.
That's correct. Yeah. A few of the resources to keep you connected in the community here. I put some links in the chat. Of course, we got the forums. I also gave you a link to the Dynamo forums. The Dynamo BIM ones they're a great resource for Dynamo users. You have the user groups. You've got the Community Voices blog, which is it's posts on a whole bunch of topics, including we have two of the authors are Dynamo experts, including one attending right now, Mr. Pearson. And but anyway, anybody can be an author in there. Just it's a fun time, good information. Student group hub, and make sure to join for the the future community conversations, the roadmap, and like Jacob said, the December 8th. And all community conversations will be paused from December 9th until middle of January, just because so many different holidays and all that good stuff.
Cool.
How's your solution doing now?
I was just going to say, let's go ahead and take a peek over that. So we only got through 11 of the 100. But typically what I see with these is it eventually settles in on a corner with each building. It wouldn't surprise me if it wound up picking out this corner and maybe down here to avoid some of those trees. But typically we get some pretty good results out of that. So I'm going to go ahead and filter that to just this for the ones that fit well. And it's kind of starting to do that. We might want to go back and revisit the weighting for our different evaluators. And that's as simple as coming back and saying, hey, trees have too much impact here. So if I take this value where I multiplied it by 10, that means I probably want to increase my fit score by another level of 0. Maybe multiply this value by a level of 10 to sort of impact that. Again, that sort of fine tuning of those outcomes is something that I typically get more involved with once I talk to the customer a little bit more and understand a little bit more what their goals are. All right, let's pop in the chat once more. Make sure we aren't missing anything. Nothing so far. All right. Well, we're clearly not going to get through all 100 in the next, what do I have? 3 minutes. But if there are any other questions, happy to answer them. Otherwise, we can go ahead and break now. Going once.
Yeah, it's pretty quiet.
Twice.
It's nice to have the good feedback too. So yeah, interesting, great demo, Minnow.
Thanks, Minnow.
Thank you.
No problem. So we'll see if we can get the Dynamo graph that I built here posted live. But I would recommend go ahead and build it on your own. Don't just run the other tools. You're not going to get as much value out of it as possible.
Hey, Jacob, you got a question. One just rolled in all the good kudos. Patrick asked, any experience of using this in infrastructure?
Yes. So I've used generative design for optimizing the location of linear elements in a sort of GIS sort of standpoint. So imagine you have a bunch of GIS data that includes stuff like, hey, there's a dense forest here. The forest is a little bit less dense there. The soil conditions here aren't good. The soil conditions there are better. Roads, bridges, other things that you might have to deal with and sort of pulling that content over. you can actually optimize it to find that path that intersects the least amount of that stuff. Another infrastructure example that I've done is, hey, what's the best way to lay out an entire city? Actually, we did urban neighborhoods as part of AU, Dieter Vermeulen and I. So you can do content like that. There's also another good example that I've sort of been playing around with in terms of what's the best way to optimize our profiles to minimize construction time as we're looking at a road project. So
I have seen, I think it was Paolo did one a while back on electrical lines running along roads for powering different infrastructure,
yep.
Subway drops and stuff like that. So
yeah, you can basically, if you can take your design problem down, whatever it is, and you can break down what those steps are and teach the computer how to not do the finite steps, right? So even when I look at this graph today, like, hey, we didn't take into account topography, we didn't take into account elevation stuff. Maybe we care more about all those other things that we're thinking about in designers as we go. We can start to kind of evaluate that stuff with a much larger sort of perspective faster through Dynamo, so that we're actually looking at stuff that the buildings always fit on site and they cut down the least number of trees overall. So
a nice comment from Robert. Fun fact, I've known Robert since before I joined Autodesk. So I was a customer back when I knew Robert, but he made the comment, pretty sure the Romans used Dynamo for their city planning.
I can neither confirm nor deny that.
Was it the end of their empire?
Maybe the start. All right.
All right,
cool.
everybody.
Yeah, well, thank you, everybody. It was a blast. I'm really glad we got to finally get to this piece, and looking forward to where we go next in all of this. Thanks all.